Hi everyone! Welcome to the Senior High School General Mathematics Qtr-1 Week-1A. Objective: the learner represents real-life situations using functions, including piecewise functions. We have the material for this learning activity video, and for the generalizations, a relation is any set of one or more ordered pairs. A relation can also be a rule that relates the domain or the set of all first coordinates of the ordered pair, and the range is the set of all second coordinates of the ordered pair. An ordered pair consists of two components, the x and the y, where x and y are all real numbers. A function is a special type of relation where each element in the domain is paired to the range only once by some rule. Also, all functions are relations, but take note, not all relations are functions. A function may be represented as 1. Ordered pair, 2. Table, 3. Arrow or mapping diagram, 4. Equation or formula, and 5. Function as a set of ordered pairs, x, f of x, and 6. Graphically. Function as a set of ordered pairs, x, f of x. A function is a set of ordered pairs x, y, where the x value appears only once in the set. Otherwise, it is not a function. The set of all x values is called the domain. The set of all y values is called the range. Function described by a table. All the points in the ordered pair can be tabulated using two rows, the independent variable row, or the x row, and the dependent variable y, and to show their relationship. Function expressed in arrow or mapping. In the tabular form, the possible values of x and y are arranged chronologically, and lines are drawn from the independent variable to their corresponding dependent variable. Function as an equation or formula. The function can be expressed as y equals f of x, where the dependent variable y, or simply f of x, is written on the left side and the independent variable x is written at the right side of the equation. Functions described graphically through inspection. The graph of a relation can easily be determined if it is a function or not. It is with the use of the vertical line tests. To do this, simply draw a vertical line passing through the graph of the relation in as many as possible points of intersection. If the vertical line intersects the graph at exactly one point, then the relation is a function. Otherwise, it is a mere relation. For example, we have the directions: read and understand, write the solution in your lecture notebook, express y equals x squared plus 5x plus 10 for the values of x equals -5, 0, and 5 in different forms. Ordered pair form, we have the same function f of x equals x squared plus 5x plus 10. Then we have the ordered pairs -5 and f of -5, 0, f of 0, 5, f of 5. Then we have here -5. Substitute x equals -5 to this function f of x. So we have f of -5 equals -5 squared, that is 25, plus -5 times 5, that's -25, plus 10. So 25 plus -25, 0, then we have 10. If x equals 0, f of 0 is, this is 0 and 0 plus 10. So we have the ordered pair 0, 10. If x is 5, then we have to substitute x equals 5 and f of 5 is equal to 5 squared, 25, plus 5 times 5, another 25. So we have 50 plus 10. So we have 60. Tabular form for the solution, we have the same function. If x equals negative 5, f of negative 5 is 10. If x is 0, f of 0 is also 10. And we have x equals 5, then f of 5 is 60. For the arrow or mapping diagram form, we have the same function. Then we have the set of all x's. We have negative 5, 0, and 5. Then we have f of x consisting of 10 and 60. If x is negative 5, f of negative 5 is 10. If x is 0, f of 0 is also 10. And if x is 5, f of 5 is equal to 60. Function as an equation or formula. For the solution, well, the given itself is in the form of an equation or a formula. So we have y equals f of x equals x squared plus 5x plus 10. And function as a set of ordered pairs. So we have to collect the ordered pair form of function earlier. Then we just simply put braces or put those three ordered pairs inside the two braces. So we have an open brace and a closed brace. Thus, we have the function in the set of ordered pairs. Graphical form of function. So we have the same function and we can use the GeoGebra in graphing. So we have here the parabola. This is the graph of quadratic function x squared plus 5x plus 10. You will notice that it is consistent with the previous forms of functions. If x is negative 5, we have f of negative 5 is equal to 10. 0, f of 0 is 10. And another one is if x equals 5, f of 5 equals 60. And you will notice that the behavior of this parabola is going upward until such time that at this point at x equals 5, we have 60. Piecewise functions. These are functions which are defined in different domains since they are determined by various equations. For example, a user is charged 2,000 pesos monthly for a mobile plan which includes an iPhone 6s Plus, unlimited same network text, 16 gigabytes data allowance monthly, and a 100 text to other networks. Text messages to other networks in excess of 100 are charged 50 cents each text. Represent the monthly cost for text messaging using the function T of M, where M is the number of messages sent in a month to other networks. So for the solution, we have T of M equals, we have two functions, the constant function that represents the monthly charge. In this case, this is 2,000, a constant. If the number of messages to other networks in 1 month is greater than 0, but less than or equal to 100. So meaning, M here is between 0 and 100 inclusively. That means inclusive. You can have your M as 0 or M equals 100 or less than that or in between 0 and 100. Another possibility is 2,000 plus quantity M minus 100 times the cost of texting to other networks, which is in this given problem, we have 50 cents. The condition is if M, or the number of messages sent to other network in a month, exceeds 100. So for example, letter A, how much will a user be charged monthly if he or she sends 200 text messages to other networks, assuming all other conditions in the previous problem are the same? The solution: since M is greater than 100, in this case, M is given to be 200 text messages sent to other networks in a month. We have here M minus 100 equals 100. So we can use T of M equals, let's recall the piecewise function earlier. We cannot use the first one, which is the constant function, because M in this case is 200. So we have to use the second function. In this case, this is a linear function. And the condition here is that M is greater than 100. So we have to solve for the amount or the charges that will be charged to the user having M equals 200 or 200 text messages sent to other networks in a month. So T of M, we copy this in the previous slides. Then T of M, our M here is equal to 200. So T of 200 equals 2,000 plus 200 minus 100, which is 100, times 50 cents. So we have the you can calculate this. The total is 2,050 pesos. Hence, the user will be charged of this amount. Moving on to enrichment activity, a person is earning 390 pesos per day to do a certain job. Express the total salary as a function of the number of N days that person works. For the solution, we have S of N equals 390 times the number of days. So it's pretty easy. The second problem, we have a taxi ride costs 40 pesos as flag down rate for the first 1 kilometer, and each succeeding kilometer or a fraction thereof adds 13.50 per kilometer to the fare. Use a function f to represent the taxi fare in terms of the distance d in kilometers. So for the solution, f of d equals 40, the flag down rate. And the condition is that the distance is from 0 to 1 kilometer inclusive. So the distance could be greater than or equal to 0, and the distance should be less than or equal to 1 kilometer. We will use this function 40, so meaning a constant function. In the case of d greater than 1 kilometer, then we will use this 40 plus the quantity d minus 1 times the rate per kilometer in excess of 1 kilometer or a fraction thereof times 1350. Okay? Take note, we have to round up because of this word or a fraction thereof. So d minus 1, we have to round this up to the nearest integer. For example, suppose a group of grade 11 students ride a taxi and the meter reading is 3.7 kilometers. How much are they going to pay? For the solution, f of d, we recall the functions that we have, but since d is 3.7 kilometers, it's greater than 1, we cannot use the first function. We will use the second function, since d here is greater than 1. And in this case, the distance is 3.7 kilometers. So we have to round up d minus 1 to the nearest integer. Let's move on to the solution further of this problem. Since d is greater than 1, obviously d is 3.7 kilometers. So d minus 1 is 2.7 kilometers. and we have to round it up. Rounding up will give us 3 kilometers. And we substitute d equals 3 in the function. So we have f of 3 equals 40 plus 3 times 1350, which gives us 80 pesos and 50 cents. So therefore, the grade 11 students having a ride or a taxi ride of 3.7 kilometers will pay this amount. Suppose another situation, the same group of students took a taxi, and after that, a taxi reading is 6.01 kilometer. How much are they going to pay? The same approach. Since d is greater than 1, d is given to be 6.01 kilometers. So we have d minus 1 is 5.01. Take note that d minus 1 exceeds 5. So we have to round up. And it's gonna be 6. And we have to get f of 6 using the second function. And this is 40 plus 6 times 1350, or we have 121 pesos. Hence, the students will pay 121 pesos for a taxi ride having the kilometer reading at 6.01. Hello, welcome to our learning activity video on Senior High School General Mathematics Quarter 1 Week 1B. Objective: the learner evaluates a function. Our learning activity material: generalizations. In the notation f of x, it is stressed that f is the name of the function and f of x is the value of f at x. If y is the value of f at x, or y equals f of x is called the independent variable, since any element of the domain can replace it. And y is called the dependent variable because its value depends on the value of the independent variable x. To evaluate functions, just replace all the values of x in the equation and simplify. Exercises 1. Directions. Read each item carefully and write the solution in your lecture notebook. Evaluate the following functions. Number 1, we have h of x equals x squared minus 3x plus 5 when x equals negative 5. So we have to get h of negative 5, which is equal to negative 5 closed quantity squared minus 3 times negative 5 plus 5. What we did is just substitute x equals negative 5 to all x's in this given function. So we have negative 5 squared is 25. Then negative 3 times negative 5 is 15. And we just copy the constant term 5 and a total of 45. For number 2, given is f of x equals x cubed minus 8 all over x minus 2. And we have to evaluate f of a plus b. Solution: we copy the function. Then since this numerator, x cubed minus 8, is a special product, and this is the difference of two perfect cube. So we have to factor this out. The factors are quantity x minus 2 times quantity x squared plus 2x plus 4. And we just copy the denominator. And since we have factors x minus 2 in the numerator and the same in the denominator, we have to cancel this out, leaving us with f of x equals x squared plus 2x plus 4. And we are now to evaluate the function at x equals a plus b. We just simply substitute a plus b in the x here in the given function or the simplified function. So we have a plus b quantity squared plus 2 times quantity a plus b plus the constant term, which is 4. Simplifying, we have this expression here is the square of the sum of a and b. So we have the expansion is a squared plus 2 times a times b, or 2ab, plus the square of b, or b squared. Then we have to distribute 2 in this quantity a plus b. So we have 2a plus 2b, and we copy the constant term. So we have now the function given evaluated at x equals a plus b. Exercise number 2. Read the problem carefully. Write the answer in your lecture notebook. The profit made by a manufacturing company producing shoes is given by the function f of x equals 4x plus 495, where x is the number of pairs of shoes sold. Letter A. How much is the profit of the company if it sold 400 pairs of shoes? And for letter B, how many pairs of shoes are to be produced if they have a profit of 4,195 pesos? For the solution, for letter A, this is the profit function given, and we are to evaluate the profit function of the company at x equals 400 pairs of shoes sold. So f of 400 is equal to, just simply substitute x equals 400 to all x's. So we have 4 times 400 plus 495. So that is equal to 1,600 plus 495. The sum is 2,095 pesos. Hence, the profit of the company is 2,095 pesos if it sold 400 pairs of shoes. Moving on to letter B, solution. We have the same function, profit function, and in this case, the profit is given. And we are to solve for the number of pairs of shoes to be produced in order to attain this profit of 4,195. So we equate f of x equals the given profit, and this is equal to 4x plus 495. We have to solve for x. So we have to transpose, from this case, transpose 495 on the right-hand side of the equation. So we have it here, and the right-hand side of the equation is 4x. Then we can interchange. This becomes 4x equals 3,700. This is from the difference of these two values here. And finally, x equals 925. Thus, 925 pairs of shoes are to be produced for the company to have a profit of 4,195 pesos. This ends our lecture discussion for this learning activity video, and see you in the next video.